I'm going to show you how to build a machine learning prediction pipeline using Upsolver. We're working on a data source with impressions and clicks, so this is an online advertising data source. And we have two streams coming in, both coming in from Kafka. The first stream is the impressions stream, so stream of basically the events of showing an ad to a customer. The second stream is the click stream, which contains the result. So if a user clicked, you will have an event in the click stream, and that's basically what we're going to try to predict. We want to know, given an opportunity to get an impression, what are the chances that there's going to be a click? So in order to do that, we need to first of all join between the two streams and extract some interesting features about the data. Now, we don't have much information at the impression level. So we have kind of the user ID and the campaign ID, but that's it. What we do have is a lot of history for each user. So users are relatively sticky. We know how they acted in the past. So I can very easily extract some relevant information from the history of the data. Doing that in Upsolver is really easy. We build an object called a materialized view, which is essentially a key value store from the user ID to, in this case, the historic click count and number of wins per campaign. So this data is available to query in real time, so can be used at inference time as well as while building the training set. This is what a query looks like of the materialized view. So we basically fill in the key here, and for whatever key we put in, we would get the value. In this case, obviously, this key doesn't exist. But this, for example, is the amount of campaigns that arrived, the amount of impressions that arrived without a user ID. And you can see that they never clicked. So in order to build a model and then use it for inference, we're going to use AWS SageMaker. And the first step, though, is to build the data set. So we're again going to do that with Upsolver using an output to S3. And in this output, we're going to calculate all sorts of features. And in addition to that, we're going to do two lookups. The first one is a lookup from the materialized view that you just saw, the ML history, which gives us a historic click count as well as the win campaign counts as a key value pair. And that's going to give us kind of the data that we're going to be using in order to learn. In addition to that, we want to label our data. So in that case, we can add a lookup from the click stream, and we're predicting here on top of the impression stream. So anytime an impression comes in, that's when we want to trigger our inference engine. And this lookup is looking into the future. So we're waiting up to an hour in the future in order to get the click. And this kind of join into data that is going to exist a bit after the event happened is again something that you can do declaratively in Upsolver without needing to worry about how everything happens behind the scenes. Now, once we run this data set, we're going to get data in S3. You can see that here. This is what training data looks like and is a format that's accepted by AWS SageMaker. So if I look at my notebook in SageMaker, it's actually really simple. This is mostly taken from an example using XGBoost. So essentially, we're going to load in the data from this bucket. In this case, we're just doing a list in order to get all the objects. And then we can see here that the data was actually loaded in correctly. We have over a day 2 million events that we're trying to use to train and validate and test. And then the rest is pretty much boilerplate, building out the training, validation, and test files, training the model, and then deploying the model using SageMaker. Now, keep in mind that for inference, we need to create a row that's identical to the one that we created in the training set. Upsolver lets you do that easily, since everything in Upsolver runs using a Kappa architecture. The exact same code that you used in training time can be used in inference time to get the results, and they would use the same state of materialized views. It's identical to what you would get if you were creating a training set. This was an end-to-end showcase of how you can use Upsolver to build a training set and also do inference using machine learning models built using SageMaker.